Hello, assalamu alaikum everyone. Uh, Today we'll discuss about the compensating and equivalent variation from the indirect utility function. And this is Rakibul Islam Rakib. Uh, currently doing my masters in SAST. My registration number is 2022 221006. And along with my friends,
Assalamu alaikum.
please give your introduction.
Assalamu alaikum. This is Rezaul Kurim. Also, my registration number is 2021 1021. And
Okay, let's start, Joel. Then the topic is about the compensating and equivalent variation from the indirect utility function. So the first question is, find this individual's Walrasian demand for good 1 and good 2. Why P denotes the price vectors, and the hints is given here, and the indirect utility function is given here, isn't it, Joel?
yes.
And we know that from the indirect utility function, we can derive the demand function using the Roy's identity. We have already know in the graduate level that using the Roy's identity, we can identify the demand of indirect utility function. Going to the next slide. And then comes the first solution. We know that for good 1, the Wallacean demand is equal to the my negative value and the indirect utility function differentiation in terms of the good 1 price and divided by the indirect utility function differentiation in terms of the wage. Here we can find the good 1 Wallacean demand function. And what can we do next? Similarly, for good 2, the Wallacean demand is same using the same equation for good 2, and we can find the individual's Wallacean demand function. And the ratio of the Wallacean demand function has been given, which shows that the demand of good 2 is a constant proportion of alpha of the demand of good 1. This constant proportion holds with any wealth level. So since goods are consumed in constant proportion, these two goods are perfectly complement, which refers to the Leontief indifference curve. And in the second question, please read the second question. Rajal Kurim Joel.
Thank you, Rakibul Haidar. You well explained in first problem A, and now I will explain the second problem where find this individual's Hicksian demand for good 1 and good 2, and given a hints, use the equivalence in this part the exercise as well, where want to go from indirect utility to function to expenditure function, and given a ratio, a Hessian demand ratio. And now please next slide where the solution is given.
Yes, and we can see that if we have to find out the Hicksian demand function, we have to find out the expenditure function first.
Yes, yes.
So from the wage function and the utility function, we have to find out the expenditure function from the indirect utility function.
Yes.
So if if we say that wage is equivalent to expenditure of P U naught and indirect utility function V PW is equivalent to mu. Then we can find the expenditure function E of P U naught is equal to U naught into P1 plus alpha P2. And then we can find the expenditure function. We use short lemma in order to find the Hicksian demands. Here Hicksian demands H1 for good one, H1 in terms of P and U naught is equal to the expenditure differentiation of expenditure function in terms of price one. Then you can find the Hicksian demand for good one, which is mu naught. And in the same, we can find the Hicksian demand for good 2, which is H2 P of U naught, which is alpha mu naught. Hence, the ratio, we can ratio the two Hicksian demand function, which is also the alpha. So in the first problem, we solve it that we found that the Wallacean demands ratio is alpha and the Hicksian demands is also alpha, which is complement. And the third question, number C, using the Wallacean and Hicksian demands you found in part A and part B, find the Slutsky equation for good one and good two. Explain your result and connect it with your intuition on part A and B.
Yes.
So the Slutsky equation can be written as follows, that as a differentiation of xi in terms of pw and divided by differentiation of xi pw. Can you see the slide?
Yes, yes.
So the two goods I and J, we can write the Slutsky equation, which is given below here in the first equation. And from the Hicksian demand in the previous part, we have found that the delta Hi P mu naught by delta Pj Pi is equal to delta Hi P u naught by delta Pj is equal to 0. So therefore, if we substitute this equation in the Slutsky equation, the Slutsky equation becomes that delta xi Pw by delta Pj is equal to minus xj Pw into delta xi Pw by delta W. This result should come as no surprise from the part A and B that goods are used in constant proportion. And in the next slide, please read out the question number D.
Okay. Question number D. Let us now assume that the initial price of good 1 get doubled. The price of good 2 is cut in half and wealth is kept constant. That is denoting by P not equal P1 not P2 not, the vector of initial prices, and P1 P to the power 1 equal P1 P to the power 1 P2 P to the power 1. The vector of final prices, we have that P P to the power 1 equal to P naught 1 for good 1, and P to the power 1 2 equal half P naught P2 naught for good 2. Now find the compensating variation CB due to the price change. Explain intuitively that what CB measures. The solution is CB. which is the monetary amount that after the price change must be given to the individuals in order to maintain him at the same independence curve. Uh, and he was before the price
Yes.
changes. The equation is CV equal E of P1 P to the power 1 and U naught minus expenditure P naught and U naught. And using the expenditure
So
function
going to the next
which
slide.
we found in part B, uh, the equation solving e to the power E of P1 U naught minus E of P naught U naught, and finally we find out the solution of compensate CB U naught of P1 naught minus alpha half P naught P2 naught. And
And what the equivalent variation measures?
measures. Okay, now
Can you say?
yes, the equivalent measures, equivalent variation measures, the which is the monetary amount that before the price change must be given to the individuals in order to make him reach the same independence curve, and he would reach after the price change. And the equation equivalent equation is E of P1 P to the power 1 U P to the power 1 minus E of P naught U to the power 1. And after the founding the part B and the exercise, we find the equivalent variation is U to the power 1 of P1 naught minus alpha half P2 naught. Please, next slide.
So it is the substituting the equivalent or equivalent value or respective value in the equation, we can find the CV and EV.
Yes.
So uh, here we easily can describe the CV and EV what measures. So the our presentation is over. We come to the
Next,
uh,
our problem is maybe
we
exercise 4.3.